Assume that the paired data come from a population that is normally distributed using a 0.05 significance level. Find D bar, S sub D, the t-test statistic, and the critical values to test the claim that mu sub D is equal to 0. So we have dependent data sets, and we are testing to see if the population average difference is 0. That would dictate a two-tailed test with alpha equal to 0.05 would put 0.025 in each tail. And one of the things that we're asked to find is the critical values, t sub alpha over 2, since it's a two-tailed test. Now we can do that using StatCrunch very easily. We'll click StatCrunch, Stat, Calculators, T. And the first thing we have to find is the number of degrees of freedom. So we go back to the problem and look and see that we have 1, 2, 3, 4, 5, 6, 7, 8 sets of paired data. So we'll have 7 degrees of freedom. In our picture here, we have 0.025 in each tail. So if I leave this at less than or equal to, and type 0.025 here and hit compute, then I'm going to get this value here, 2.365, when I round to 3 decimal places. But it's minus because we're to the left of the mean here. So less than 0. So if I have, in other words, with this curve, if I have 7 degrees of freedom and I have 0.025 of the area out in this tail, the corresponding t-value is minus 2.365. I can find the very same thing by making this greater than, and then making this 0.025 so that 0.025 of the area is in the upper tail. That gives me the positive 2.365 value, which we see here in the problem. I am also supposed to find the sample average difference. That's what D bar stands for. I can do all of this very easily using StatCrunch. First, we'll hit this little rectangle here that copies that data set to a table that I can paste into StatCrunch. I'll push data, load data from paste, paste the data in the box. Realize that these pairs are separated by commas, so I'll have to select comma in the delimiter. I'll also notice that the first line represents the name of the data here, so use first line as column names, leave that checked, and hit OK. Now that enters then the data into these two columns in StatCrunch. Now, since these are paired data sets, I'm going to go to t-statistics, paired, sample 1 will be X, sample 2 Y, and hit next. Now we're doing a hypothesis test. The problem told us that the mean difference is 0. That leaves the alternative hypothesis to be not equal to. Now we'll hit calculate. And right here, the sample difference, 2.75, which is what we have here, D bar, 2.75. The t-statistic is given here, 2.868 when we round to 3 decimal places. Now that leaves this S sub D. This table gives us the standard error, 0.9589801. But what that standard error is the standard deviation of the differences divided by the square root of the sample size. So if we think about this, 0.9589801 is equal to S sub d divided by the square root of 8. We had 8 paired data values up there. So if I want to find S sub d, all I'd have to do is multiply both sides by the square root of 8. S sub d equal to 2.712, as we have here.